Hello friends, in the last lecture we have learned inverse by elementary transformation method. In that we have taken examples of order 2 by 2. Today we will take examples of order 3 by 3. So how to find the inverse of matrix which is of order 3 by using the elementary transformation method. See the example. We have given a matrix A 1 3 3 1 4 3 1 3 4. We have to solve this by using elementary transformation method. So for any type of inverse, first we have to take the determinant of the given matrix 1 3 3 1 4 3 1 3 4. Find the determinant 1. Delete this row, this column 4 3 3 4 minus 3 times delete this row, this column 1 3 1 4 plus 3 delete this row, this column 1 4 1 3. So 4 4s are 16 minus 3 3s are 9 minus 3 times 4 1s are 4 minus 3 plus 3 times 3 1s are 3 minus 4 1s are 4. 1 into 7 minus 3 into 1 plus 3 into minus 1. 7 minus 3 minus 3. So 7 minus 3 is 4 minus 3. Answer for the determinant is 1. So is it 0? No, it is not equal to 0. Therefore, A inverse exists. A inverse exists. So this should be the first procedure to find the inverse. First check the determinant. If it is not 0, then we can say its inverse exists. And now we will find the inverse. How to find? Consider A into A inverse is equal to identity. Consider A into A inverse is equal to identity. This we already have taken for 2 by 2 matrix. And now I am taking again for the 3 by 3. For the 3 by 3 operations are little bit complicated. We can see this taking some more examples. So you will get to know how to solve it easily. I am writing here matrix A. I am taking this example from the solved example of the textbook. Actually this is the simpler example, and next I will take little bit difficult example. So see how this is simple. Since the procedure is for I3, means to make the matrix A into identity matrix of order 3 by 3, first make this element 1. Using this one, make these elements 0. This is the first procedure. First make this element 1. Using this one, make these two elements 0. So we already have here 1. Now using this one, we have to make this element 0 and make this element 0. Means operation is on R2 and operation is on R3. Operation is on R2 and operation is on R3. We can take these operations separately in the separate two procedures. We can take this two together. Whichever is convenient for you, you can do it. R2 minus, which element I have to take here? 1 minus 1. This element will become 0. So R2 minus R1. Similarly, this is 1 and 1 minus 1 will be 0. So R3 minus R1. R2 minus R1 and R3 minus R1. So 1 3 3 elements of R1 same. 1 0 0 elements of R1 same. Operation here R2 minus R1. I am writing here operations. R2 elements are 1 4 3. I am writing this 1 4 3 0 1 0 minus elements of R1 1 3 3 1 0 0. So 1 minus 1 0. So we are getting here 0 since R2 minus R1. This operation is successful now. 4 minus 3 1. 3 minus 3 is 0. 0 minus 1 is minus 1. 1 minus 0 is 1 and 0 minus 0 0. So next one, R3 minus R1. R3 minus R1. So I will do this operation on the separate page so that I can take the next operation following this. So R3 minus R1. Elements of R3 are 1, 3, 4, 0, 0, 1. 1, 3, 4, 0, 0, 1. Minus elements of R1. Elements of R1 1, 3, 3, 1, 0, 0. So 1 minus 1, 0. 3 minus 3, 0. 4 minus 3, 1. 0 minus 1, minus 1, 0 minus 0, 0 and 1 minus 0, 1. Okay. So the procedure is that to make the I3, that is matrix of order 3 by 3, that should be the identity one, 1, 0, 0. Using this one, make this two elements 0. We already have made this element 0. So next procedure is to make this element 1. This is again of same type which we already have solved for 2 by 2. So make this element 1 and using this one make these elements 0. Using this one make these two elements 0. So how will we make these elements 0? We already have this element 0. We have to make this element 0. See here we are getting here 1 directly. So no need for the operation to make this element 1. So 3 we have to make it 0 using this one. So we'll know 3 minus 3, this element will get 0. So how to make 3 minus 3? Here it is 1. If I multiply the second row by 3, so 3 ones are 3 and 3 minus 3 will become 0. Obviously operation is on R1 because we have to change this element, and there will not be any operation of R3 because we are directly getting here 0. So R1 minus 3 times R2. R1 minus 3 times R2. So R2 row will be same. Here R2 row will be same. R3 row again will be same. R3 row again will be same. So we'll have operation R1 minus 3 R2. I am doing this here. R1 minus 3 R2. So elements of R1 1, 3, 3, 1, 0, 0 minus 3 times elements of R2. 0 elements of R2 I am writing here 0, 1, 0 minus 1, 1, 0. So 1 minus 0, 1, 3 minus 3, 0, 3 minus 0, 3, 1 minus minus is plus 3, 4, 0 minus 3, 0 minus 0 is 0. Okay. So next was R1 minus 3 R2 and we are getting this element 0. That means your operation is successful here. Now what should be the next procedure? First make this element 1. Using this 1 make this element 0. Now make this element 1. Using this 1 make this 0 and make this 0. Next procedure, make this element 1 and using this 1 make these two elements 0. So first make this element 1 and using this one make these two 0. See this, we are already getting here 1 and using this one make this element 0. Using this one make this element 0. So operation is on R1. So what we will do, R1, if I have here 3, multiply this row by 3 and subtract it from R1. So R1 minus 3 times R3. R1 minus 3 times R3. A inverse as it is. And the second row 0, 1, 0 minus 1, 1, 0 will be as it is. Third row will be as it is. And R1 minus 3 times R3. I am doing this operation here. R1 minus 3 times R3. What are the elements of R1? 1 0 3, 4 minus 3 0, minus 3 times elements of R3. Elements of R3 0 0 1, minus 1 0 1. So I am writing here R1 minus 3R3. 1 minus 0 1. I am writing here 1. Then 0 minus 0 0. 3 minus 3 0. 4 minus minus plus 3 7. Minus 3 minus 0 is minus 3. 0 minus 3, that is minus 3. So see, this element is getting 0, means your operation is successful. So R1 minus 3R3, I am writing this operation, and we have done this operation. We are getting here the matrix, identity matrix of order 3. So what is this identity matrix? I into A inverse 7 minus 3 minus 3 1, 1 minus 1 1 0 minus 1 0 1, and identity into any matrix is the same matrix. So finally we'll write the answer A inverse as 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So this is the final answer. 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So this is little bit complicated procedure to make I3. I2 was very easy. For I3 this procedure is little bit longer, and there are so many calculations, and we have to do it correctly. So I am writing the procedure again here for the shortcut. First, make the element of this row and column as 1. Using this 1, make this two elements 0. Next step is to make this element 1, and using this one make the other two elements 0. Then make this element 1, and using this one make the other two elements 0. This is the procedure for I3 and elementary transformation method. And see this, we have done this procedure. See this two elements 0, then making this 1, using this 1 make this element 0, then using this one make the other two 0. Go through these examples, and we'll take in the next lecture we'll take examples of your exercise. These all examples are for 4 marks, and they are all important for your exam point of view. Thank you, friends.